So in this question, I'm given triangle ABC and triangle DEF, which are similar. And I have the triangles below, and some of the side lengths are labelled up here. I can see that each of the kind of relating angles are the same, so all three angles in both triangles are the same, they've just been kind of scaled up by a different amount. I'm asked to work out the length of DF, which is this length here of the second triangle. So in order to kind of work with this, I need to understand the concept of similar shapes, and similar shapes are kind of basically when one shape has been uniformly scaled up to become a different shape, the same shape, just kind of a different size of it. All angles are preserved, it's just the side lengths which have changed. And these have changed by some sort of scale factor here. So if I can calculate this scale factor, I can work out the length of DF and how much greater it is than the kind of corresponding length of AC on the original shape. So if I have a look at my shapes, the length AB and DE are effectively in the same position relative to the angles that are the same, so we can work out the scale factor between these two. And I can work out that scale factor by taking the larger one, so the second one of 12.6 in this case, dividing that by 8.4, and that gives me an answer of 1.5. So 8.4 multiplied by 1.5 gives me this value of 12.6 centimetres for the length of DE. So similarly here, if I take the 6.4 and multiply that up by the scale factor of 1.5, I'm going to get the new length of this length here, DF, which is what I need to calculate. So I take 6.4, multiply that by 1.5, and that is going to give me an answer here of 9.6, just using that ratio. So the final answer here is 9.6 centimetres, and that's going to get me the second mark for this question. This first mark was for finding the correct ratio, so finding this as 1.5 if we're going from the first shape to the second. Alternatively, you could work back from the second to the first, and then you'd end up with a ratio of 0.66 recurring. But either way you do it, you'll come to the same conclusion of 9.6 centimetres for the length DF. So now for the second part of this question, we're asked to work out the length of CB, which is this length of the first shape this time. So last time, when we used our scale factor of 1.5 and multiplied it by the length on the first shape to get the length on the second shape, this time we're going to need to work with it slightly differently. So instead of multiplying by the scale factor, because we're going from the second shape, this length of 15 between these two angles, to this length here between the same two angles, we need to divide by the scale factor of 1.5 this time. So I can take this length of 15 and divide that by 1.5 in order to find the original length on the first shape. So instead of multiplying up by the scale factor, we're dividing by the same scale factor. And this gives me an answer of 10 centimetres, which is the correct length for CB. And we could check that if we were to multiply 10 up by the scale factor, we'd get 10 multiplied by 1.5, it does give us 15, so this does work in the other direction. So we'd gain the mark for getting the 10 centimetres correct, and for doing this calculation here using the scale factor, using that ratio from the previous part of the question.